Alright, this is continuing section 11.4, the product rule and the quotient rule. We're just differentiating the problem. The problem is number 4. The function is q of x equals x squared plus 3x times 7x squared minus 5. Now you can multiply through and just differentiate without using the product rule, but we are learning the product rule in this chapter, so let's use it. Let's call the first equation f of x, the second one g of x. So you don't actually have to do this. I'm just doing this just to demonstrate that there are two functions, and I take the derivative of the first one and leave the second one alone, and then add the derivative of the second one and multiply by the first function. So you don't actually have to identify them physically by actually writing out what they are, what they're called, and then writing out the rule. I'm just doing it just to show you. And after a few problems, I'm not going to do it anymore. I'm just going to take the derivative, and that's ultimately what you should be doing. So okay, so the derivative of the first function is 2x plus 3. We're going to multiply that by the second function, which is 7x squared minus 5. We're going to add now the second function, the derivative of the second function, which is 14x. Multiply that by the original function, which is x squared plus 3x. Alright, so let's expand some terms here. We've got the first term, we've got 14x cubed minus 10x plus 21x squared minus 15 plus 14x squared plus 42x squared. Sorry, 14x cubed plus 42x squared. Alright, so now let's just combine some like terms. We've got the cubed, we have 28x cubed. And in the squared terms, we have 21 plus 42, that's 63x cubed, minus 10x, minus 15. And there you have it, folks. It's a meaty derivative, lots of terms in it. You just got to be careful with these problems when you're just doing like the algebra, like the basic algebra, because you could get the method right, but if you get the algebra wrong, you're going to get the wrong answer, and we're all going to be very sad. Very, very sad.